Hello guys, welcome to Deep Course, and today in this video we will discuss LeetCode question 2532 that says time to cross the bridge. So here we are given k workers and n boxes. The workers have to move these n boxes from from right to left. So assume that there is a river and that has two banks. The river that has a right bank and the left bank. All the boxes initially are present at the right bank and you need to move it to the left bank, right? And you have k workers to do your task. Further, or initially all the workers are present at the left bank. So what type of movement would be done is a worker present at the left bank will go to the right bank, pick the box, then move again from right to left and put the box. So this is the movement of the worker here. Further, each action will take some time. So here we are given left to right I. That denotes the time taken by worker I to move from left to right. Pick old I. That means a time to pick the box from the right bank warehouse. That is the old warehouse. Further, right to left of I. That means the time taken by worker to move from right side of the river to the left side of the river. And put new of I. That means the time taken by worker to put that box into the new warehouse after coming to left bank. Okay. Further, we have to calculate efficiency at some of the stages. So here efficiency is defined as time to move from left to right plus time to move from right to left. Okay, so this defines the efficiency, and the greater the time, the more the less the efficient. Okay, it's obvious, the more time if a person takes, it is less efficient, right? And if for two workers the efficiency is same, then check for I greater than check, means check for the index, right? So now there are some rules to regulate the movement of workers in the breach. So if a worker X reach the bridge while worker Y is crossing the bridge, X wait at their side on the bridge, means at a time only one worker can cross the bridge. The second is, if a bridge is free, then first priority is given to workers present in the right side of the bridges, so they can cross. If more than one worker is waiting on the right side, then we will give priority to the worker with the lowest efficiency. Okay, and if a bridge is free and no worker is waiting on the right side, then the worker present on the left side will cross, and from that the worker with the lowest efficiency will cross the bridge first. Okay, so I will show you graphically so that you will understand this question more in a better way. Let me take the first example here, and I will show you graphically here. Okay, so here n represent the number of boxes, k represent number of workers, and these are the values of the workers. So the first here, this is the time array. So the first index I represent left to right, time needed to move from left to right. This will indicate that now this second time bit indicates time to pick the box. The third time indicate time to move from right to left, and the fourth time indicate time to put the box. Okay, got it. So here this is like some river thing. We have bridge, and here we have new warehouse, here we have old warehouse. All the workers are present at the new warehouse initially. One worker with the lowest efficiency move to the right, pick the box, then move to the move to the left, put the box. Then another worker will do until all n boxes from the old warehouse are put to the new warehouse. So this is the definition of a question. So for each worker, let's calculate the efficiency here. Worker 1, for worker 1 efficiency is 1 plus 2, that is 3. Worker 2 efficiency is 1 plus 3, that is 4. And worker 3 efficiency is 4 plus 1, that is 5. So your efficiency is time needed to move from left to right plus time needed to move from right to left. So this is how we calculate efficiency. Now, as the question says, if there are more than one workers, then we will select the worker with the least efficiency. So here this is a river, this is the bridge. Okay, initially we have worker 1, 2, 3 on the left hand side near the new warehouse, and all warehouses has 3 boxes. Box 1, 2, here only one box is there, as this says, and is column only one box is there. And we need to calculate the total time, we need to return the total time. Okay, so we have 3 workers, we will prioritize worker 3 as it has the least efficiency. So the worker 3 will move from let's track the movement of worker 3 left to right. Okay, plus it will pick, plus it will move right to left, plus put. So the total time would be 1 plus 4 plus 1 plus 1. So 4, 5, 6, 7. So 7 is the total time. But as you can see here, our answer is given 6. That is because when we return 6, because the problem asks for instant at which last worker reaches the left bank. So the thing is, if worker 3 here is the last worker, so if it is the last worker, we won't add the time to put that box. Okay, so we will only calculate till here. So here answer is 6. If there are multiple workers moving through this bridge, so for the last worker we won't add the time for put. Okay, got it? Yeah. So moving ahead, as you have seen here that we will prioritize the worker with least efficiency, right? So whenever we will be calculating the least efficient worker based on the time, we will use one. So to do that, we will use priority queue, or you can say maxif, and we will inside the maxif we will store the time, right? And with the whichever the maximum time would be present at the topmost element. Okay, correct. And further, we further to put and pick, we will use min heap, and here we will prioritize the worker with lowest put and pick time. Okay. Okay, so I hope you got the approach, somewhat idea of how we would solving this question. So this question is a bit complex to understand, but once we start writing the code, we will understand it in a much better way. So and you understood why you are using a maxif here and minheap here. Okay, so now let's move to the coding part. Okay, let me first take priority queue. I will take pair of int comma int, and I will name it wait underscore left. So this will store workers waiting on left side. Then I will again also take one another priority queue that will store workers waiting on the right side. Okay, now I will take one more priority queue that will be the min heap int comma int vector var int end greater var int int. So and that would be pick, and one another same priority queue that would be put. Initially all the workers are present on the left side, so we will update wait left. So for all integer I equals to 0, I is less than k, I plus plus wait underscore left dot push time of 0 plus time of 2 comma I. Okay, it is time of I comma I and 0, I and 2. So this is the time to move from left to right, this is the time to move from right to left, and in overall we are calculating and pushing the efficiency in this wait underscore left. Okay, now we will calculate the while loop while n greater than 0, or not wait underscore right dot empty. So there are no more workers on the right side, or no one is left to pick, or no one is left to put. Okay, the first thing what we would do is set up ordering for the right side. That means if we have any workers who came and picked the parcel, then we push them to the wait right queue. Means if a person has picked the parcel, then push them to wait underscore right. Correct? So this is the first thing we will do here. While not pick dot empty and then pick dot top dot first. So this first will store the time if it is less than equal to t. So t is, we can say, current time. Let me initialize this int t equals to 0 and last and t equals to 0. So the last will store our answer, that is the last person who came to the left bank, right? As we need to return this, the last worker who reaches the left bank. So we will store in this, and this is our general time. So if a person has picked the parcel and it is, then we have to add that worker into the right wait queue. So let me take one auto current pick to top not pop, and now wait underscore right dot push. Okay, we will push that worker with the help of this index. Time of index 0 plus time of index 1 plus t, that is the total. We are not adding t here, we will add t in the later. Okay, so this is what we did is we put a person with a parcel to the wait right queue. Now the same thing is we have to do if a person is on the left hand side and he has put his parcel on the new warehouse, then we have to add him to the wait left queue. Correct? So while not put dot empty and then put dot top dot first is less than equal to t, then what we would do is we would do the same thing as we did for the pick part. We will add it to the wait left queue. It is the time of index 0 plus time of index 1 and the current index. Okay. Now if there are workers on the right hand bank, that is in right side of the bank, then we'll prioritize them first. So if not wait underscore right dot empty, and in the else part we would check for workers waiting on the left side. So here in this, what we would do is if n is greater than 0 means if there are any boxes remaining, and then not wait underscore left dot empty. So these two if condition, now we have to write it. So yeah, if a person is waiting on the right side, then he will move to the left side, right? So we are just doing that. Auto efficiency and index equals to wait underscore right dot top wait underscore right dot pop, and we will also calculate the last put here. Instead of last name it as last put for better understanding. So last put equals to maximum of last put comma t plus time of index and 2. So this is the time to move from right to left, correct? And we would now push this worker who has moved from right bank to left bank into this put. So because he will put that box, put dot push t plus time of index 2 plus time of index 3, that is the time to put that box, and along we will add the index. We will increment time to this time t2 index and 2, so that is time to move from right to left, and we would continue. Okay, continue for the other. So we would continue this loop, correct? Now we would write for this wait left condition. That means if a worker is waiting on the left bank to move to the right bank, right? So here we will take the same thing, efficiency index from the wait left. We would simply opt that element. Once it is waiting on the left hand side, then we have to add that to pick, because its next task is to pick the box. So we will add that dot push t plus time of index 0 plus time of index and 1. It is the time to pick, and we will also pass the index. We will also increment the total time of index and 0. Right, so till here I hope you guys understood this. We will decrement this n with not total number of boxes left, and we will continue. Okay, now if there are no boxes left, then we have to check for the last the time when the last person arrived on the left bank, right? So here in this case I will just take one p10, that is the last put time, is int max. Now if not pick dot empty, so if there is some boxes that is picked still, then I will update p time to minimum of p time and pick dot top dot first. If not put, that means if some box is left to put, then I will also update this p time same as this with the topmost element of the put. Now if p time is not equals to int max, that means some of these two condition has been fulfilled. In that situation we will update our time to t to p time, and in the else condition we will simply break. And in the end we will simply return the last put. Okay, so this last put is, here we have updated the last person who moved from right bank to the left bank. Okay, so now let us try to run this. This is a bit complex code, so much to take care. Okay, we got some error now. Let us try to look what's the error is, what wrong we did. Here at both the places 2 will come, that is the time taken to move from right to left. Okay, and I think everything is great here. Okay, so here the time 3 will come, that is the third is right to left, right? Sorry, the third is time to put new, so that will be added to this put. Okay, now I think everything is great now. So yeah, now let me try to submit this. Okay, so our code got accepted. So let me just now brief you out. So this both we take 2 queues to that will store the efficiency, and we will get the least efficient worker, because at the topmost of this maximum heap will be the person who takes the maximum time, correct? Then we this wait left will store all the person who are waiting on the left bank, so we initiated wait underscore left. Then further we check for if someone is left to pick or someone is left to put that box, then we did both this action. If no, then we check if any person is waiting on the right bank If this is false, then yeah, we would move here. If the person is waiting on the left pane, then his next aim is to pick the box. So it will take time of more time to move from left to right and time to pick. Correct. And similarly, if a person is waiting on the right side, then the time would be time to take to move from right to left and time to put. So this is a bit confusing, but I hope you guys understood the solution. So that's all for this video. Make sure you like the video and subscribe to our channel. Thank you.